Next, on the inside of our foldable, let's talk about some properties of working with exponents. When we are adding or subtracting terms that have exponents on them, we simply combine like terms. And we did this a lot last 6 weeks when we added or subtracted polynomials, or even when we multiplied, and after we multiplied, we would always combine like terms at the end. So the only thing we're doing when we're adding and subtracting is we are just simply combining like terms. So let's take a couple of these and look at these examples. If I have 9x squared plus 9x minus 3x squared, I notice that I have two terms that have an x squared. So those are like terms, and I can combine them. And when I do that, I only change the coefficients. That base term raised to the exponent is not going to change. So 9 minus 3 will give me 6, and I keep the x squared. And then plus 9x, it didn't have anything to combine with. So that's my final answer. 2x squared minus 2x squared plus 1. Well, these are complete opposites of each other, so they are going to cancel to 0, and so I'm just simply left with 1. Now let's look at a couple of more challenging examples. If I have 9x squared y minus 10x squared y, notice again that I have bases and exponents that are the same. X squared and y occurs in both of these monomial terms. So all I need to do is add or subtract with the coefficients. So 9 minus 10 is going to give me a negative 1. Don't usually write the 1, but I will say negative. And then the like part is x squared y. The last one, we want to subtract 6w from 8w. The key word here is the word from. So that means that I need to start with 8w and subtract 6w from it. Well, that's going to give me 2w. 8 minus 6 is 2, and the w doesn't change. Next, let's look at our zero exponent property. And our zero exponent property says that we have anything raised to the 0 power, it is always equal to 1. It doesn't matter what it is. It can be a small number, it can be a big number, it can be a combination of numbers and variables. It doesn't matter. If it's raised to the 0 power, the answer is 1. Let's take a look at that. So 4 raised to the 0 power is 1. This great big number, let's see, we've got something a little over 98 billion, I think that is, but raised to the 0 power is still equal to 1. You can prove that to yourself by putting one of these in your calculator. Just pick some great big random number and raise it to the 0 power, and you'll see that it ends up being 1. Let's take a look at these more challenging examples. If I have 1 plus negative 30 to the 0 power, well, negative 30 to the 0 power is simply a 1. Add that to the 1 that was already there, and I get 2. If I have parentheses, and that parentheses contains both numbers and variables, so coefficients and variables, 50x plus 300y, but the whole thing is raised to the 0 power, it is also equal to 1. Now let's look at our negative exponent property. And whenever we see a negative exponent, there are two things that we need to do in order to get rid of that negative. First is we're going to take the reciprocal of the part that's raised to the exponent. So we'll take the reciprocal, and after we take the reciprocal, then that exponent that was negative is going to become positive. So let's look at a couple of examples. If I have 4 raised to the negative 2 power, I'm going to take the reciprocal of 4, so that's 1 over 4, and I raise it to the positive 2 power. Now this one we can actually evaluate. We can say 1 divided by 4 squared, and we know that 4 squared is 16. If you're not sure, use your calculator, but it'll give you 1 over 16 as a final evaluated expression. If we have negative 2 to the negative 5th power, the part that's raised to a negative power is the negative 2, so that's going to become the reciprocal, so 1 over negative 2, and now it's raised to the positive 5th power. That's going to give me 1 over, then negative 2 to the 5th power. Use your calculator if you're not sure, but we're multiplying negative 2 times itself 5 times. That's going to give me minus 32. One final, more challenging example. In this case, we are starting with a fraction, so we have 1 over 3 to the negative third. The reciprocal of 1 over 3 is simply 3, and that negative third power, or negative cubed, is going to become a positive. Remember, take the reciprocal of the part that has the negative exponent on it, and then change that exponent to positive. 3 to the third power, 3 times 3 times 3, 27.